Hello students, welcome back. So in the previous session, we had learned about queues. We have completed learning the data structure queues. And today we are going to start a new data structure, which is linked list. As you all might be knowing, previously when we were implementing stacks or queues, we have come across this particular data structure, which is linked list. We had implemented the stacks and also we had implemented queues using this particular data structure. So at that point of a time, we had briefly understood what it means. So today we are going to see it in detail. Today and in coming sessions, we are going to learn more about this particular data structure. Okay, so let's go ahead and start. So what is this linked list? A linked list is a linear collection of data elements called nodes. Okay, so this is very important. In linked list, we call the data items as nodes. And the linear order is given by means of pointers. So these are the two important things. So in linked list, we are going to have a node, okay, which looks something like this. And each node will have a data section and also it will have a link section. Now this link section is nothing but a pointer. Now this pointer is something which points to the next node. So the entire linked list you can look into as a chain of nodes, okay, which are connected to each other in the form of links, through links, right? So each node contains two part fields, as I said, the data and the reference to the next node. This reference is nothing but the link section, right? Now, the first part contains the information and the second part contains the address of the next node in the list, okay? So this is also called as a link field. Now, if I have to compare array and linked list, what is the difference between them? Now, arrays, we know that arrays are always, they are nothing but the consecutive memory location, isn't it? We already know that they come one after the other. So if this is 100 and if my each memory location is of 1 byte, then I can easily say that this is 101, this is 102, 103. So there is no need of a link here. Why? Because it has to have a continuous memory location. But if at all we have a memory where the memory is scattered, I have a memory something like this. So in order to declare an array, I need continuous memory location. Suppose I don't have continuous memory location. I have scattered memories like this. So in such cases, we can easily use linked list. Why? Because we can declare this as one node, this as another node, this as another node, and using the link or the address part, I can easily link them, okay? So this is what the benefit of linked list on arrays. In order to declare an array, we have to have a continuous memory location, wherein which in linked list, we don't need a continuous memory location in the memory. All we need to do is we have to link the next memory location using the pointer. Okay, so this is the basic details about linked list. And what are those? Linked list is a linear collection of data items. It has nodes. It is a collection of nodes, and each node will have a data where we store the actual information, and the other part is called as a link where we store the address of the next node, right? So let's go ahead and see what do we have next. So next, see this example, okay? So I have something called as a head. In linked list, I always have something called as a head, or this you can also see it as a start node, right? Now, this always holds the address of the next node. So see this here, 4800 is nothing but it is the address of the next node. So this is a node. Okay, similarly, this is my second node, this is my third node, and this is my fourth node. Now, the start node always contains the address of the first node. So when I come to this particular memory location, this is where my data is stored. So the data of this particular node is 10, and in the link node, it has the another address. Now this address is linking at the next node, which is stored at this particular address, which is 4900. Similarly, this node has a data item which is 15, and in the link part it has the address 5000. So it is pointing at the address 5000 where we have our third node stored, and this third node has a data 5, and this node is also pointing at another memory location or another node which is stored at the address 3000. So 3000 is here. This one has a data item 20, but in this case, see this carefully, the address part is null. So whenever we encounter null in the address part, this means that this particular node is the last node of this linked list. Clear? So see this, the above picture is linked list with 4 nodes. Each node contains 2 parts. The left part of the node represents the information part. As I said, data part. This is also called as information part of the node. The right part represents the next point field. Okay. So why? Why? Because it is pointing at the next node, isn't it? That contains the address of the next node. A pointer start gives the location of the first node, which is nothing but this one. It is called as a head or it is called as a start node. Okay. Now this pointer is also represented as head. As I said before, this is also called as a head. Now, what are the types of linked list? There are basically 3 types of linked list. Okay, which are those? The first one is a singly linked list, second one is a doubly linked list, and third one is a circular linked list. Now, what is the meaning of this? Let's see them one by one. The first one, which is nothing but singly linked list, means it contains 2 fields. Okay, in each node, the data field and the link field, which is nothing but what we saw just now. This is the basic one. Basic linked list is called as a singly linked list. The data field contains the data of that node, while the link field contains the address of the next node. Since there is only one link field in each node, the linked list is called as singly linked list. Okay, since we have only one link field, okay, we are going to call this as a singly linked list. The next one we have is circular linked list. Now, what is the difference between this and singly linked list? So, see here carefully. In list, if the link field of the last node contains the address of the first node, such a linked list is called as a circular list. So, what is happening here? In the previous, which was the single linked list, we had the last part containing null. Okay, the last node has the address part null. So in that case, it is called as a singly linked list. Wherein which in my circular linked list, look here carefully, the last node has the address part has some values. It is not null. It has some values. And what is that value? The address over here in the last node is nothing but the address of the first node. Okay, so in that way, we can say that this is like a circle. They are connected to each other. That is why this is called as a circular linked list. So in a circular linked list, it is possible to reach any node from any other node. Okay, why? Because I can come to the last node. From the last node, I can go back to the first node and I can go on like this. So that is why this is called as a circular linked list. The last one is called as a doubly linked list. Okay, now as the name says, this one has double links. Okay, so it is a linked list in which each node is points to both the next node and also to the previous node. So look here in this image, I have a single node here. In the middle, I'm going to store the data, wherein which the other 2 parts are the link part, where this one is going to point to the next one and the first one is going to point to the previous node. That's why this is called as a doubly linked list, because it has double links, right? Now, what is this? Back. It is a pointer field containing the address of the previous node. So which one is back here? This is nothing but our back. Forward is a pointer field that contains the address of the next node. So this is the forward node. Why? Because it is going to show us the next node. Info contains the actual data. So my info is going to come over here. Okay, I hope this is clear. This is our doubly linked list. Now, in the first node, if back contains null, it indicates that it is the first node in the list. Now, what is the meaning of that? Like I said, I have a node something like this. This one is always going to point at the back and this one is going to point at the next one. Okay, suppose this first one is null. This means that there is no other node before this. which means this is going to be my first node. That is why there is no other node before this. Similarly, the node in which forward contains null indicates that the node is the last node in the linked list, which is very obvious, isn't it? Consider this doubly linked list node. If my last node or the forward node of this one is null, which means there is no link to the next one, which means that this is my last node. Clear? Now see here, this is how a doubly linked list is going to look. We are going to have nodes where they are linked to forward and backward, both the sides, right? So see, this is the very first one where my backward link is going to be null. Similarly, my last node is going to have a forward link as null because this is the last one and this is my first node. I hope this is clear. So this is all about doubly linked list. Now let's go ahead and see what are the various operations which we can perform on linked list. There are 6 of them. The very first one is creating a linked list. How can we create a linked list? This can be using algorithm also. This can be using a program also. In the coming session, we are going to learn a program about how can we create a linked list. Okay. Next is traversing. Traversing is nothing but visiting each node. Okay. So how are we going to do that? We are going to learn that as well. Inserting an item into a linked list. Now, how do we do this? Okay, deleting an item, searching an item, and merging an item. So these are the 6 operations which we can perform on a linked list, which we are going to learn in detail in the coming sessions. Okay, so that's all in today's session, students. I hope this has been informative and it is helping you in your preparation. Thank you for watching. Take care.